In front of you is an advanced humanoid robot called U2 from Navi AI, which is actively learning and already demonstrating real-world application scenarios. It is an upper-body platform focused on precise manipulation and work in industrial and service environments. One of the key demonstrations is screw fastening using visual servoing. The robot detects holes with cameras, aligns the tool, and performs precise fastening with high repeatability, a level required for assembly lines. In addition to autonomous tasks, Navi AI is developing teleoperation, where an operator wearing a VR headset can control the robot in real time, transmitting arm and torso movements, allowing U2 to sort objects, work with tools, and even cook by replicating human motor skills. The company also demonstrates applications in retail, where the robot recognizes products, adaptively grasps objects of different shapes, and interacts with the surrounding environment. Toyota developers have presented a new revolutionary project called WalkMe, an innovative next-generation wheelchair that does not just roll on a surface, but literally walks on robotic legs. Unlike traditional wheelchairs, WalkMe is equipped with 4 independent robotic supports that allow it to overcome steps, uneven terrain, curbs, and other obstacles in urban environments. Instead of wheels, it uses walking modules with advanced stabilization that automatically analyzes the surface and adjusts movements in real time. One of the key features is the ability to climb stairs without external assistance. Built-in sensors and balance algorithms calculate the center of gravity, adjust the body position, and ensure smooth, safe movement up and down. Additionally, the chair can raise the user to the level of a car seat, simplifying getting in and out. Unitree Robotics developed an innovative platform for full-body teleoperation and embodied avatars and tested it on their humanoid robot G1, turning the machine into a kind of remote human body. This embodied avatar system allows an operator to control the robot's movements in real time, almost one-to-one replicating human gestures, steps, and actions. In the demonstration, the operator in a special suit and VR headset transmits hand, torso, and leg movements to the robot. The robot synchronously mimics the poses, maintains balance, and manipulates objects. This is not just remote control. The system integrates full-body tracking, motion sensors, and stabilization algorithms to compensate for signal delays and preserve stability during rapid movements. If the operator steps forward or swings an arm, the robot interprets the trajectory and safely reproduces it considering its own center of gravity. Meet probably the friendliest and most human-like robot named Yogi, a humanoid with a special focus on interaction, emotions, and assisting people in everyday life. This robot was developed by the American company Cartwheel Robotics, not just as a mechanical device, but as an emotionally and socially oriented companion robot. Its appearance and proportions are deliberately designed to be friendly and childlike. A rounded body, a large head, and soft shapes inspire trust and do not intimidate, even when Yogi is around children or elderly people. The robot is approximately 130 centimeters tall and weighs around 30 kilograms, compact enough to move comfortably around a home or office while remaining stable and balanced for daily interaction. A humanoid robot began working at the Sany renewable energy production site, becoming one of the first examples of real-world deployment of human-like robotics in an industrial environment. The model is the UB-Tech Walker S2, which started performing tasks at a smart factory equipped with 5G infrastructure and a digital production management system. Unlike demonstration videos, here the robot operates in an active enterprise environment. Walker S2 performs sorting, transporting, and precise manipulation of parts, adjusting grip strength and body position depending on the object. Thanks to the built-in computer vision system, it recognizes items on the workbench, determines their orientation, and corrects its movement trajectory in real time. Integration with the 5G network allows the robot to exchange data with the production system without delays. This enables it not only to perform tasks autonomously, but also to receive updates, transmit telemetry, and operate within a unified digital ecosystem of the enterprise. Recently, Deep Robotics released several videos showcasing their advanced RoboDog M20. In the first demonstration, the robot actively prepared for winter testing inspired by the atmosphere of the Winter Olympics. M20 moved confidently across an ice arena, performed maneuvers on slippery surfaces, and demonstrated stability during sharp turns. Engineers tested its balance, wheel-leg traction, and ability to adapt to a dynamic environment where any wrong move could cause it to lose stability. In the second demonstration, M20 was subjected to extreme cold conditions. Tests took place in the snowy fields of Humanoid at temperatures down to -30 degrees Celsius. The robot moved through deep snow, overcame uneven terrain, wind, and icy patches, confirming the stability of its electronics and actuators in harsh weather. Testing showed that the control system and battery module maintain functionality even in severe frost, and stabilization algorithms allow it to keep balance on loose and slippery surfaces. In China, the humanoid robot Kepler K2 is already deployed on real production lines and is gradually working alongside humans in industrial settings. This is not a show prototype, but a fully operational platform designed for heavy and potentially hazardous tasks. Kepler K2 is a full-size industrial humanoid about 170 centimeters tall and weighing roughly 65 kilograms. Its body is made of durable composite materials and metal, built to operate in factory conditions. The robot is equipped with powerful servos, enabling it to lift and hold significant loads, as well as perform precise operations, including welding and manipulating large components. One of K2's key features is collaborative high-altitude welding. The robot works together with humans in high-risk zones. Thanks to computer vision and depth sensors, it accurately positions the welding tool, maintains stable force, and ensures consistent welds, reducing worker strain and improving safety in the facility. Lately, people increasingly forget the original purpose of humanoid robots. Not for flashy demonstrations, but for real work in environments initially designed for humans. This idea is embodied in the launch of the Atom U Ultra platform, a new generation of intelligent robots focused on practical application. Atom U Ultra is positioned as a step toward a robot out of the box, a system that does not require complex setup or lengthy configuration. At the core of the platform is a modern VLA model that integrates vision, command understanding, and action execution into a single architecture. This allows the robot to perceive visual information, interpret text or voice instructions, and immediately translate them into physical actions. In demonstrations, the humanoid confidently handles objects on a table, sorting, moving, and adjusting grip strength. Its movements are smooth, and manipulations are precise. The robot analyzes situations in real time and adjusts action trajectories accordingly. Write in the comments what you like the most after watching this video. Subscribe to the Karo Show channel so you don't miss the next episodes. Bye for now.